Welcome! In this series of short videos, we will give an introduction to those who have never used Power Basic before or even considered taking up programming. Today we will look at version management. What is it? How does it work? And what benefits could it bring to Power Basic programming? So what is version management? How can I use it? And what is it for? Before we answer that question, let us consider your development process. You write code on a computer, and everything goes well, until you find one morning that your computer will not power up. The machine has failed, or the storage medium has been corrupted. You've lost the code you were working on. Do you have a backup? A less dramatic scenario, and probably more common, is where you've deleted or changed some part of your code and you need to get back to a previous version, preferably without having to remember what it looked like and having to rekey it. Is version management more than just backups? Firstly, you can never have too many backups. It's a really good habit to get into. You never know when you'll need them. And it's vitally important to check that a backup system is actually working. Finding out that it's broken after you need it is really bad news. Version management goes further than just mere backups and should be used in partnership with traditional backups. So what can I do with version management? In order to answer this question, we need to look at some scenarios. Some applications may need only a handful of source files. Others can require hundreds or even thousands of files. Let's look at a very simple but common scenario. You have produced the first version of an application, and this has been released to your users. You have further enhanced it to a second version, and this too has been released. So encouraged by your success, you start to work on version 3, which may well involve some big changes to your code base. However, while you are working on version 3, some serious issues are reported with version 2 that need to be fixed. Your dilemma now is that your development team is committed to version 3 and may have already amended much of the code for that planned release. Ideally, you need to have access to the code as it existed when version 2 was released. You need a code time machine. This could be a backup taken when version 2 was released, or, preferably, a version management system that keeps copies of every change made to your code base. We need to branch the code base at version 2 to allow some of your team to work on and build a fixed release. Let's call that version 2.1. Branching is the easy bit. Once version 2.1 is released into the wild and the issues the users experienced have now been resolved, you now need to fold those changes into the development work happening for version 3. This is what would be referred to as a code merge. It would not be well liked by your users that a fix made on one release became unfixed in a subsequent release, so your updated code base may well contain new files as well as amended ones, depending on the nature of the fix. A good version management system will be able to report the differences between any two builds, and even assist you with the merging of code changes. Having successfully merged your code fix into the main trunk of development, and tested it of course, it can then be released, and your team can go back and look at the next version's work. Branching can be used for longer than one release. Sometimes entire new products are formed by branching off a code base at one point, and that key fork marks the beginning of a new product, which will never be folded back into the original trunk. Having a way to visualize your development path allows forward planning of where you're going to take your product. This can become a roadmap for planning future releases. So what terminology is it helpful for you to know? Product. The name of the system or application. Your product is likely to have a common name that everyone knows it by and is referred to in your documentation. This may be totally different to the names of the binary files within the product. Deliverable. The name of an element of a product. Each product can be comprised of a number of deliverables. For example, one executable, 4 DLLs, graphics files, templates, etc. Version. The incremental ID of the product or deliverable. Each product and deliverable, and even each file within a deliverable, should have a version number that allows you and your version management system to identify what groups of files would be in a particular release. Deliverable type. This is the definition of what the deliverable actually is. If a deliverable is a PowerBasic application, is it a PowerBasic Windows or console application? Is the deliverable a database comprising of many SQL scripts, or is it documentation or graphics? Deliverable source, where the source files for the deliverable are actually stored. Knowing where the deliverable files are stored in the version management system is vital, as deliverables could comprise a single file or many thousands of files. Deliverable build script, the definition of how deliverables are built or delivered. Some deliverables can be built by running a build script, for example, building a PowerBasic application on the command line to obtain your exe or DLL. Other deliverables may merely need copied to a location. One special deliverable, which is run last, may encapsulate all the other deliverables into an installation package. Build repository. Once you have built a version of your product, you need to store it somewhere. And that location should be a write once, read many times location. The builds themselves should be versioned. Build status. Detail of a specific version of a build. You need to know the status of each version of a build. For example, your product may ship out being called version 1. However, that version may have gone through 5 build cycles. Builds will have a workflow, going from not yet started, through building, built, in test, and finally either pass test or failed test. Builds that fail testing will obviously need to go through another cycle of development, and builds that actually pass testing become candidates for release. It's never too early to consider doing version management. There are many version management toolsets out there, from free to very expensive. Each of them has their own special qualities and features, but all are designed to make your programming life easier, or at least give you a way to recover from development issues. For the single developer, the ability to see what has changed in your codebase before you check new code in helps you to identify and debug code you left in by mistake, and also allows you to get back code you have inadvertently deleted. For both small and large teams, knowing who changed code, when they changed it, and why is always useful, allowing you to coordinate the work of many staff and possibly disparate teams to produce your valued products. I've deliberately avoided covering or mentioning any specific version management systems, as everyone's needs are different. But hopefully this video has given you some things to think about. But that's it for today. Thank you for watching.